In this video, we're going to be talking about the transformation of functions. And then we're going to do some examples where we're going to shift some functions. So we're going to start off by looking at a quadratic function in general terms where we can see the values for shifting and stretching and what do each of those mean. So let's review what each piece means. Our front negative goes with reflecting in the x-axis. Our m represents a vertical stretch or a shrink. If we have a number larger than 1, it will be a stretch, and a number that is less than 1 will be a shrink by those factors. The negative on the inside represents the reflection in the y-axis. The factor inside goes with horizontal stretches or shrinks. Remember that if we have a number that is less than 1, that will reflect our stretch. And if we have a number larger than 1, that will mean that we are shrinking horizontally. Our h moves the graph left and right. Left if we see a plus sign, and right if we see a minus sign. Remember that all of the things inside lie to us. They say one thing and they do another. And so we see a plus, we go left. We see a right, we go, we'll see a minus sign. So just remember that. And then our k is responsible for shifting the graph up or down. Up if we see a plus sign and down if we see a minus sign. And those rules apply to all parent functions, whether it's linear, quadratic, cubic, rational, square root. It works for them all. So we're going to do some examples now where we're going to use the graph of f of x equals x to the third to sketch the graph of the following. Now notice that here we have a cubic equation, but our rules up top will still apply. Our f of x equals x to the third is what we call the parent function. It's the pure equation where no transformations have happened yet. So we'll begin by graphing the parent function. And you can either use your calculator to get that if you don't have that memorized. You can just plug that into the y equals and just put x to the third and then sketch that graph. So let's take a look at our first example. Here we have g of x equals x to the third minus 1, and our g of x is the new equation. A shift has happened. Something has happened. So here we see the difference from the parent function to letter A is that minus 1 value. And that minus 1 value means that we're going to be moving our graph down. So in order to graph this, we are simply going to move our center point down 1. Oops, there we go. And then we're going to graph it. It has the same curves. We just moved it down 1 spot. Let's take a look at our second example. Here we have x minus 1 all raised to the third power. So our 1 is on the inside. So would you say that looks more like the m or the a or the h or the k? I think it looks more like the h because it's on the inside. And we see a minus sign, so that tells us we're going to move to the right. So here we're going to move to the right 1. So we're going to start at our 0, 0 spot, and we'll move to the right 1, and then make the same equation. So we'll move to the right 1 and graph our equation. I'm going to have you try letter C on your own, trying to determine which way we're going to shift our graph. Push pause and figure out the answer. When you're done, push play and let's see if you're right. So here we have a number on the inside, like the H, and in the back with a plus sign, like the K. So here we're going to have two shifts happening. We're going to move it left 2 and we're going to go up 1. So we're going to take our graph and we're going to move left 2, and then we're going to move up 1, and that's going to be where we start our graph. And there we go. And so now we have our graphs of f of x, which are our green functions that we did originally with no shifts. And then we have our red functions, which are our g of x, our h of x, and our k of x, which show our shifts. So that is how you can use this equation to help you in sketching the graphs of functions with transformational shifts.